Yes. Good morning, all. In the last class, we stopped somewhere here in the structure of atmosphere, right? Now, let us start with the structure of atmosphere. Structure of atmosphere. If at all we are taking one column of atmosphere, suppose if this is Earth and it is atmosphere, it is the surface of the Earth where we are living here. Suppose if this is the area where we are living. And if we take one column of atmosphere, what do I mean by one column of atmosphere? Vertically, if at all we are taking up to the space, one column of air like this, vertically, some area, only this much of area. This column is called as the column of atmosphere. How this column of atmosphere was divided into? It was divided into different layers, like the first layer, second layer. Who has divided this one? Did we divide it or what? Or is it naturally divided? It is naturally divided. How we came to understand that there are different layers based upon the behavior of temperature. Based upon the behavior of temperature. It is the temperature which is very important parameter of the weather conditions which is behaving in an unusual way. Like somewhere at a particular height it is increasing, somewhere in other at another height it is decreasing with the height. This is what is happening, and therefore based upon the changes in the temperature we have divided the atmosphere into different layers. The first and foremost layer in which we are living is called as troposphere, which extends right from 8 kilometers to 18 kilometers, meaning what, over polar region it is just 8 kilometers, whereas over the equator it is 0 degrees, nothing but equator, it is up to 18 kilometers. This is the first layer called as troposphere. Then up to next 50 kilometers it is called as stratosphere. Then the next up to 80 kilometers it is called as the mesosphere. Then up to next 400 kilometers is called as ionosphere, or otherwise called as thermosphere. The last one, which is called as exosphere, where the outer limit, could you see this outer limit? The outer limit, we are unable to give this outer limit. Till now, the people are having a lot of ambiguity, confusion regarding the outermost limit of exosphere. These are the different layers. Let us start with our first layer called as troposphere. What is this troposphere? Troposphere is an unevenly distributed layer. The first point. It is unevenly distributed layer. It is unevenly distributed layer. What do you mean by unevenly distributed layer? It is not uniformly distributed. Somewhere it is more, somewhere it is less. Less in height from the surface, more in height from the surface. Why this uneven distribution is there? There are two reasons for this unequal distribution. One is called as along the equatorial region you can find high temperatures. When the temperatures are very high, you can find the radiation also high. The other reason for this one, the gravitational force. As you know that Earth is acting as a huge magnet, but the gravitational force is not equally distributed. The gravitational force is more at the polar regions, whereas the gravitational force is less along the equatorial region. Because of less gravitational force, nothing but less pull, the extent of the gases has raised to greater height here. But because of more pull, the gases came very close to the surface. Moreover, the temperatures are also less here. Therefore, the gas particles are highly dense and you can find all the gas particles located in a very limited area. That is the reason why the troposphere is an unevenly distributed layer. Tropos in the Latin language. Tropos in the Latin language means what? Mixing. It is called as mixing. Therefore, it is called as the mixing layer. Tropos in the Latin language called as mixing, and it is a mixing layer. What is mixed here? All the gas particles, all the water vapor, all the water vapor is mixed. Because of mixing of all the water vapor and the gas particles and all these things, it is highly a turbulent layer. It is highly a turbulent layer. What do you mean by turbulent? Nothing but disturbance. You can find very great disturbance. What type of disturbance you can find? You can find rainfall. You can find cyclones. You can find all the weather disturbances. Whatever the weather disturbances are there, all the weather disturbances are related. You can find tornadoes, you can find hurricanes, all these are restricted only to the troposphere. You cannot find any such disturbance above the troposphere. Why such a disturbance is restricted only in the troposphere? Because 75%, this point is very, very important. 75% of the mass of the atmosphere is present in the troposphere. Out of all the layers, see here, all there are so many layers. Which is having more density? It is, where do you find more mass? It is only in this layer. How much mass is there? 75% of the mass of atmosphere is restricted only in the troposphere. Not only 75% of the mass, 99% of the moisture is also located here. 99% of the moisture. What do you mean by 99% of the moisture? 99% of water vapor. 99% of the water vapor is present here only. Because of 99% of the water vapor, 90% of the clouds are present here. You can find all the clouds restricted to the troposphere. When all the clouds are there in the troposphere, also you can find all the turbulence, weather disturbances, all the weather disturbances related to the earth are restricted to the troposphere. In the troposphere, you can find a very important phenomenon called as the normal lapse rate. It's called as normal lapse rate. What do you mean by lapse rate? In fact, lapse rate is nothing but the change in the temperature with respect to height is called as lapse rate. Change in temperature. When we say it is change in temperature, nothing but it is called as change in temperature. When we say it is change in temperature, it can be increasing temperature, the temperature may increase, or the temperature may decrease. The change in temperature with respect to altitude. What do you mean by altitude? Nothing but height. The change in temperature with respect to height is called as lapse rate. There can be increasing height with temperature. There can be decreasing height with there can be decreasing temperature with respect to height. There can be increasing temperature with respect to height. Any change, whenever the temperature changes with height, is called as lapse rate. Then what do you mean by normal lapse rate? Whenever there is a uniform lapse rate. A uniform lapse rate. What do you mean by uniform lapse rate? Nothing but continuously the temperature is changing according to certain height. Like, what do you mean by the positive lapse rate? Let us understand this one. What do you mean by positive lapse rate? Positive lapse rate is nothing but if temperature decreases, see this one, if temperature decreases with height, if temperature decreases with increasing height, this is called as positive lapse rate. Normally, what our mind will believe, whenever there is increasing, something is increasing, what we call this one as positive. But here in the lapse rate concept, whenever the temperature decreases with height, meaning what? If at all you are moving vertically up, if at all you are moving vertically up, if the temperature decreases, this is called as positive lapse rate. Opposite to this one is called as the negative lapse rate. What do you mean by negative lapse rate? Whenever the temperature increases, whenever the temperature increases with height, whenever the temperature increases with height is called as negative lapse rate. This is negative. This is negative lapse rate. What is uniform lapse rate? Uniform lapse rate is a positive lapse rate, but the temperatures are changing at regular intervals, like for every 165 meters of ascent. For every 165 meters of ascent, meaning what? If you go to a height of 165 meters, 1 degree of temperature will be reduced. For every 165 meters of ascent, ascent means what? Whenever you are moving vertically up, 1 degree of temperature is reducing. Or else, if at all we are converting this one in kilometers, for every 1 kilometer of height, 6.5 degrees centigrade. 6.5 degrees of centigrade of temperature will be reducing. This is what is a normal lapse rate. What is normal lapse rate? This equation is very important. What is normal lapse rate? For every 165 meters, suppose if it is surface and you are moving vertically up like this one. If it is 165 meters, 1 degree, suppose the temperature here is 30 degrees at the surface. If you move to 165 meters, the temperature will be 29 degrees centigrade. If you move further 165 meters, then again the temperature is reducing. Likewise, for every 165 meters, you can find decrease in the temperature. This decrease is called as normal lapse rate. This is called as normal lapse rate. Then, this is about the troposphere. Whenever you are crossing right from the troposphere into the stratosphere, there is a transition layer. The transition layer, which is of 2 kilometers of width, which extends between 6 kilometers to 8 kilometers at poles and 16 kilometers to 18 kilometers at equator. 16 kilometers to 18 kilometers at equator. This transition layer is called as tropopause. The transition layer is called as tropopause. What is this tropopause? Tropopause is a transition layer between the troposphere and the stratosphere. The next layer is called as stratosphere. What is this next layer? Stratus. Stratus in the Greek language means what? Layers. This layer is layered in nature. Meaning what? Suppose if this is a stratosphere, this is layered in nature like this one. It is divided into layers. Who is dividing this one into layers? This is called as inner stratosphere. This is called as outer stratosphere. Who is dividing this stratosphere into different layers? It is a very important layer called as ozone layer. A very important layer called as the ozone layer. The ozone layer is called as biological shield. It's called as biological shield. Why it is called as the biological shield? Because it is protecting the life, bio, on the surface. Suppose if this is the life that is present, suppose this is the life that is there, this ozone layer is absorbing the very harm ultraviolet rays that are coming from the sun, and it is filtering the ultraviolet rays. Therefore, the people here along the surface are saved from the harmful ultraviolet rays. Therefore, it is called as biological shield. It was a great personality by name Mr. Chapman who has discovered one unique phenomena here. What he has discovered, the unique phenomena, Chapman has discovered that in the presence of nothing but the sunlight, in the presence of sunlight, the oxygen atom is meeting with the molecular oxygen to form the larger molecule called as ozone. But in the absence of absence. What do you mean by absence of photo? When there is no photo. When there is no photo energy. What do you mean by photo? Nothing but sunlight. When there is no photo energy, the larger O3 molecule is splitting into again O2 plus 4. And therefore, Mr. Chapman has called this one as Chapman reaction. He called this one as Chapman's reaction. What is this Chapman reaction? Nothing but he called this reaction as ozone is nothing but ozone is a photochemical effect. What he said? Ozone is a photochemical effect. This is what he said. What do you mean by photochemical effect? In the presence of photo, a chemical reaction is happening and forming the larger molecule called as ozone. This is what the very important equation called as Chapman's reaction. Not only the Chapman's reaction, there are some other people who are associated with this ozone called as Mr. Brewer and Dobson. Brewer, Dobson. And this Dobson is very famous personality because He is one who has discovered many phenomena regarding the ozone, and even the thickness of ozone layer. The thickness of ozone layer is measured in the units called as, what are the units called as? They are called as DUs, nothing but Dobson units. Called as Dobson units. The thickness of ozone layer. How much thickness is there for the ozone is measured in which unit? It's called as Dobson units. These two personalities, in fact, the Dobson's disciple was Brewer. He was a scholar of Dobson, right? When Dobson and Brewer were working on the ozone, they could discover one circulation. They call the circulations as Brewer-Dobson circulations. They call these circulations as the Brewer-Dobson circulations. These are the circulations they discovered in the ozone layer. This is about the ozone. What is the current related development with respect to ozone? It is the ODS substances, nothing but ozone depleting substances, especially CFC. Chlorofluorocarbons are making the holes for the ozone layer. Where do you find the holes? If it is the Earth, along the Arctic, along the Antarctica, there are huge holes. If this is ozone like this one, if this is ozone like this one, where you can find huge holes that are there. These are called as the ozone holes that are discovered over the Arctic and Antarctic. This is about the CFC. Then in the inner stratosphere, the inner stratosphere is isothermal. What do you mean by isothermal? There is no change in temperature with respect to height. There is no change in temperature with respect to height. With respect to height. If this is the height, there is no change. Even though you are moving vertically up or coming down, there is no change in the temperature. Therefore, it is called as isothermal layer. Whereas outer stratosphere, unique phenomena is happening. What is that one? There is a increase in temperature with increasing height. Meaning what? There is a negative lapse rate. There is a negative lapse rate. This is what is happening in the outer stratosphere. Increasing temperature with the increasing height is found in the outer stratosphere. This is about the stratosphere. The next layer is called as the mesosphere. The next layer is called as the mesosphere. Mesosphere, the literal meaning of meso. Meso means what? Middle. As this layer is located in the middle, see this one, under this one there are two layers. One is stratosphere and one is the troposphere. On the top of this one also you can find the two layers. One is called as ionosphere, another one is called as the exosphere. As it is located in the middle, therefore it is called as meso. Meso in the Greek language means what? Middle. What is this meso layer famous for? In fact, in the meso layer, there is a very important phenomena called as the positive lapse rate. What is positive lapse rate? Decreasing of temperature with increasing height. And in fact, because of this one, this is the coldest. This is the coldest layer you can find, of all the atmospheric layers. Which is the coldest layer? This is the mesosphere. The temperature dips to almost all minus 100 degrees centigrade here in this layer. Though it is a coldest layer, but it is a dense layer. Because of less temperature, high density is there. And all the gas particles acts as a very thick layer like this one. All the gas particles acts as a thick layer, and never they will be allowing any rocky material that is coming from the space. This is space. If this is a mesosphere, this is where the surface, this is where we are. This is the mesosphere. Mesosphere is like this something. When it is a dense layer, so dense layer and it is very cold layer, when any rocky material, suppose a meteorite is coming. What is a meteorite? Nothing but a rocky particle or a dust particle which is coming from the outer space. Suppose if it is coming because of the friction, as this material is coming with a greater velocity, some thousands of kilometers per hour is the velocity of this rocky material. Whenever they are coming, as these layers are dense layers, they resist the entry of this one. When they resist the entry, there is a great friction. Because of the great friction, what happens? All this rocky material burns. Burning of the dust particle happens. We can literally see right from the surface, like something is burning. Whenever something is burning, it will be emitting some light, and we call this one as star is falling. Such star which is falling is called as shooting star. Where do you find the shooting stars? Shooting stars are found in the mesosphere. And so, as it is chemically very active, this layer is also called as chemosphere. This layer is chemically active, therefore it is called as the chemosphere. What do you mean by shooting stars? Nothing but the material that is glowing due to burning of the dust particles, burning of the any rock particle or any dust particle. When all this material is burnt, where it is called as meteor. This is called as the meteor. The rocky material, which was solid material, burns into dust particles like this one. This is the meteor you can find. These are called as the shooting stars. Where you can find the shooting stars? It is in the mesosphere. And this mesosphere is also called as the chemosphere. The next layer is called as ionosphere. What do you mean by ion? This is called as ionosphere. Why it is called as ionosphere? Why it is called as thermosphere? As you can find, all the atoms are in the ionic state. What do you mean by atom? What is the ions? What is the atom? Atom is a basic building block of our universe. What is the structure of the atom? Whenever you are dividing any particle to such a stage where further no division happens, such a small invisible particle is called as atom. In the atom, you can find the protons and the neutrons, whereas the electrons, which are negatively charged particles, will be revolving around the nucleus, and the electrons are exactly equal in number to that of the protons. This is the standard structure of an atom. Sometimes what happens, some of the larger atoms comes and they will be taking one of the electron because of their great capacity. When the electrons are taken, suppose one electron is jumping from here to this atom. This is also atom, this is also having protons, this is also having neutrons. What is the general structure? Equal number of electrons should be there. But when, because of the greater attraction, when one electron is taken, now protons became more here. Now electrons became more here. Such a unequal electrons to that of protons are called as ions, which is a charged particle. This is called as the charged particle. It is positively charged, it is negatively charged. Therefore, it is called as a charged particle. These charged particles are the one which are responsible for increasing temperature with increasing height. Because of increasing temperature with increasing height, this phenomena called as negative lapse rate. What you can find in the ionosphere or thermosphere, negative lapse rate is found. The temperatures increases with height, and this is the very hot layer, the hottest layer of atmosphere. The temperature rises to even around some 1000 degrees centigrade. This is what the ionosphere or thermosphere. In this layer, you can find two very important layers. In this layer, you can find two very another important layers, as this layer is completely composed of ions. One layer is called as E layer, another one is called as F layer. What is the E layer? E layer is the one called as Kennelly, heaviside. It is called as Kennelly heaviside layer. What is this layer? This is the charged particle which is capable of reflecting the long wave radiation, and it is helpful for short distance communication. This layer is very much helpful for short distance communication. Whereas there is another layer called as F layer. This layer is called as also called as Appleton layer. This layer is also called as Appleton layer, which is helpful for long distance communication. Long distance communication. Meaning what? As they are the charged particles, they are capable of reflecting the radio waves which are coming from the surface. When the radio wave is reflected by the E wave, that is helpful for short distance communication. But if it is reflected by the F layer, which is useful for long distance communication. Beyond this one, you can find the another layer called as exosphere. Very little is known about the exosphere. This exosphere, the outermost limit is not known yet. Outermost limit, outermost limit is not known yet. At the same time, all the atoms in the exosphere are in the rarefied form. All the atoms are in the rarefied. What do you mean by rarefied? RARIFIED. They are all independent in nature. There is no bondage between one atom and the other atom. All the atoms are highly independent. There is no question of formation of molecule. Therefore, these individual atoms are nothing but they are called as the rarefied form. A very little is known about the exosphere, and even the outermost limit is not known. But the people understood that beyond, if at all you are going beyond the exosphere like this one, there is another layer called as magnetosphere. It was named as a magnetosphere because of the magnetic property, and they believe that this magnetosphere is believed to be the sun's atmosphere. It's not the atmosphere of the earth, it is the sun's outermost atmosphere. This is about the exosphere. In between every layer, see this, in between every layer, there is a pause area. There is a pause area in between every layer. Like whenever you are talking about the tropopause, I have explained only tropopause. What is this tropopause? Tropopause is the transition layer between the characteristics of tropos and the stratus. And on the same lines, in between every layer, there is a transition layer. The transition between mesosphere and the stratosphere is called as stratopause. The transition between mesosphere and the stratosphere is called as stratopause. The transition between mesosphere and ionosphere is called as the mesopause. The transition between ionosphere and the exosphere is called as ionopause. It is ionopause. And as such, there is no such transition between any such layer called as exopause, right? Up to the ionopause, you can find the transition layers. These are the transition layers. What is the pass region? The characteristics are being passed. Suppose whenever you are moving from the mesosphere into the ionosphere, the characteristics of the mesosphere are being passed and the ionosphere characters start. That is the transition layer. This is about the structure of atmosphere. After understanding the structure of atmosphere, let us start with the first very important weather parameter. How many such weather parameters are there? The first one is called as temperature, the next one is called as pressure, the third one humidity, the fourth is winds, fifth clouds, sixth precipitation. These are the six very important weather parameters. Let us start with the first one called as temperature. What do you mean by temperature? Temperature is defined as the degree of hotness or coldness of a body. What is temperature? Temperature is defined as the degree of hotness or coldness of a body. Is called as temperature. This temperature is being transported from two different sources on the Earth's surface. Suppose if this is the Earth, what is the source of temperature for the Earth? There are two very important sources. There are two sources. The first one is called as the primary source, and the primary source is from the sun. Sun is the major supplier of heat energy on the surface of the Earth. Or most of the energy, like 99% of the Earth's heat energy is because of sun only. Nevertheless, there is another source called as the primordial heat. It's called as the primordial heat. What is this primordial heat? That heat that was trapped in the deep inner layers of the Earth during the formation of the Earth. During the formation of the Earth, what happened? Such heat energy got trapped. Some heat energy got trapped. That heat energy, even today, now and then, will be keep on coming out. Where it is called as geothermal energy. It is called as geothermal energy, and it will be keep on coming out now and then in the form of volcanism. In the form of volcanism, it will be keep on coming. Or even there are certain vents called as the thermal vents. Thermal vents are nothing but the small openings over the ocean surface where they will be emitting the heat energy. This is called as the heat energy that is coming from the deep inner layers of the Earth, called as primordial heat. The primary source is the sun, and also there is a heat energy supplied onto the surface of the Earth due to the trapped energy that is present in the inner layers. These are the two very important sources for heat energy on the surface of the Earth. But the question is how the sun's energy is transmitted onto that surface. Modes of heat transfer. Modes of heat transfer. Let us see different modes. What are the different ways of heat transfer? The first one, foremost one is called as radiation. The first and foremost is called as radiation. The second one is called as conduction. The third one is called as convection. What are the three very important modes of heat transfer? There are three important ways. One is called as radiation. The next one is called as conduction. The third one, convection. What do you mean by radiation? The transfer of heat energy through electromagnetic waves. Electromagnetic waves. If the heat energy is transported through the electromagnetic waves, meaning what? When the sun is giving the energy, somewhere it is Earth. There is no contact between the Earth and the sun, but the energy that is emitted by the sun is in the form of electromagnetic waves. These electromagnetic waves, when they touches the Earth's surface will be receiving the heat. This is called as electromagnetic wave transfer. Whereas conduction, what do you mean by the conduction? Transfer of heat energy due to contact. The transfer of heat energy due to contact, meaning what? Suppose if there is a candle, if it is a candle, and if you keep a small iron piece and you are holding the candle here, what happens after some times? You cannot hold the iron piece. Why this iron piece? Or maybe a spoon. Take a spoon, keep a spoon to the candle on one side and hold the spoon on the other hand. Hold like this one. Whenever you are holding like this one, then what happens? You cannot hold for longer time. Why you cannot hold for longer time? Because the heat is transmitted from one end of the spoon to the other end of the spoon. This is what happening. This side, though you are not heating the spoon, yet the heat energy is transported. Such transfer of heat due to contact is called as conduction. Then the last one called as convection. What do you mean by convection? The transfer of heat energy due to the changes in the density. the transfer of heat energy due to changes in the density. Meaning what? Suppose if this is a gas particle, that means the atmospheric gas particles are here like this. When the atmospheric gases are there, when the sun is making the earth's surface to get intensely heated, the earth will be releasing the heat energy. When the earth is releasing the heat energy, or suppose the land got heated up, put it like this in a very simpler way. The land got heated up and all these gas particles are in contact. When the gas particles are in contact on the surface, due to contact, the heat energy transfers, which is called as conduction. When this air packet absorbs the heat energy, this becomes light in weight and it moves vertically up like this. Suppose the temperature here is 30 degrees centigrade. When the heated gas particles reaches here, what happens? The temperature increases here. The temperature increases here, or else the temperature may be here 20 degrees centigrade. But now the heated gas particles, when they came here, now the temperature is in this area is 30 degrees. Such a transfer of heat energy due to changes in the density. This is the high density area. Here the low density area. Why the gases are moving vertically up? As they got heated up, they want to cool, therefore they are moving vertically up. Such a change of temperature or such a movement of temperature from one area to another area due to change in the density is called as convection. This is what we'll be seeing very commonly. If I explain this one in the form of technicality, like I need to use density in all these things. Suppose if this is a surface, what you will be seeing during the daytime, you can see literally with your naked eye, like some of the air gases or some of the air particles, they are moving vertically up. Especially whenever you are seeing the national highways, if you are there in the national highway during the summer, you cannot see the surface of the road very clearly. Why? Because on the long distance where the road and the sky is meeting, we feel like it is something glazy. What is the glazy? The air packet or the air particles which are superheated, they are moving vertically up. That is what called as convection. These are the different modes of transfer of heat. When the sun is one and the same, now see this one. When the sun is one and the same, the sun is giving the same amount of insulation to the entire earth. When the sun is giving the same insulation to the entire earth, suppose if this is earth's surface, why different places are having different temperatures? Meaning what? Factors affecting the temperatures. Factors affecting temperatures. Let us see the factors. When the sun is one and the same, why the different cities or different places on the earth's surface are having different temperatures? There are certain factors that are affecting. Like the first and foremost factor is called as latitude. Latitude is a very very important factor where it is affecting the sun's insolation, nothing but sun's energy. What do you mean by insolation? All these things. Let us see this one. The first one is called as latitude. The second one is called as altitude. The third one is called as the distance from the sea. Distance from sea. Then the fourth very important one is called as the tilt of the earth and the tilt of the earth. The fifth one, ocean currents and air masses. The sixth one, transparency in the atmosphere. The transparency in atmosphere. The transparency in the atmosphere is also a very important factor, and also there are some other factors. But these are all the very important factors that are affecting the temperature over the surface. When the sun is one and the same, there are different temperatures over the surface. Like Delhi is having some temperature, Hyderabad is having one more temperature, and if at all you are talking about some other countries like Switzerland is having one temperature. right? These are all the different areas having different temperatures. Why all these things are happening? Because of these factors. One is called as latitude, altitude, then the distance from the sea, tilt of the earth, then ocean currents and air masses, transparency in the atmosphere. These are the major factors. What do you mean by the latitude? Suppose the earth surface, suppose this is the earth, suppose this is the earth. I have taken only half of the earth like this. This is equator, right? When the sun rays are falling over the equator, what is the shape of the earth? The shape of the earth is called as geoid. Meaning what? It is flat at the poles. It is flat at the poles. It is somewhat bulged at the equator like this. It is bulged at the equator. This is what the shape of the earth. When the sun rays, suppose I am taking two sun rays. Let us take two sun rays like this one. Okay, these are the two sun rays that are reaching the earth's surface. One sun ray is touching the earth at the equator. This is the area. When the sun ray is touching the earth at the equator, the area occupied, see this one, this is the area. This is the area occupied by the sunlight. The area occupied by the sunlight is very less. A little area is occupied, but whereas whenever the sun ray is touching at the polar region, because the shape of the earth, more area is covered by the sunlight. Got the point? This area is very less. When the energy is coming from the sun and it is touching the earth's surface along the polar areas, because of the curvature, the area occupied by the sunlight is more, whereas along the equator the area occupied is very less. Whenever the area occupied is less, then what happens? All the heat energy is concentrated in one place. But when the heat energy is scattered and it is distributed to more area, what happens to the concentration? The concentration will be less, the intensity will be less, and therefore the temperatures are low here, whereas the temperatures here are high. Both the sun rays are having the same energy, but some sun rays are giving high temperature, some sun rays are giving low temperature because they are distributed. See this one? The sunlight that is reaching the earth's surface at the polar region is distributed to a larger area. It is something like, suppose this is a paper, take a torchlight, invert the torchlight. Whenever you are inverting the torchlight, what happens? The torchlight will be falling perpendicularly, and the area occupied by the light is less, but the lightning, the intensity of the light is very high. Intensity of the light is very high. But when you turn the torchlight at an angle of some 45 degrees like this one, then the light occupying the area is more. The light occupying area is more. But what happens to the intensity? Intensity will be less. Exactly this is what is happening. When the sunlight is falling perpendicularly, this is called as the angle of incidence. Very, very important. What do you mean by angle of incidence? At which angle the sunlight is hitting the earth's surface? If the sunlight is reaching the earth's surface perpendicularly, then the temperatures are high. If the sun rays are reaching slantly, if the sun rays are reaching slantly, then the temperatures are low. This is the scenario. Here along the equator, the sun rays are reaching perpendicularly, whereas along the poles, the sun rays are reaching slantly at an angle because of the curvature of the earth. Right from here, you can keep on curvature. Right from the equator, the earth is curved like this. Therefore, whenever you are moving right from the equator towards the polar regions like this one, as and when you move right from the equator to the polar regions, the temperature will keep on increasing. which is called as the sign of the latitude. More the sign of the latitude, more the sign of latitude. What do you mean by more the sign of the latitude? Meaning what? More the number of latitude, right? 90 degrees latitude, less the temperature. 90 degrees latitude means what? Equator, less the temperature, less the sign of latitude, less the sign of latitude, more the temperature, more the temperature. Less the sign of latitude, meaning what? 0 degrees, 1 degree, 2 degree latitude, 3 degrees latitude. What type of temperature you can find? High the temperature. This is called as the angle of incident. The first one called as latitude. The next one is called as altitude. What do you mean by altitude? Altitude is nothing but the height. Suppose if this is surface and this is the mountain. If a person is here and if a person is here, who is close to sun? This guy is close to sun, but this guy is very far away from sun. But he'll be having low temperatures. This fellow will be experiencing high temperature. Why this reason? Why the though this fellow is far away from the sun, why he has to face more temperature? There are two reasons. One is called as the distribution of gases. Another one is called as terrestrial radiation. Terrestrial radiation. First one, let us see the distribution of the gases. Whenever you are seeing the distribution of the gases, how the gases are distributed? The gases are distributed very densely close to the surface like this one. The gases are distributed very densely close to the surface. As and when you are moving vertically up, the gases are definitely there, but the gas composition, the gas quantity will be becoming less and less, like this one. This is what is happening. Whenever you are seeing the gases, this is the distribution of the gas. In the upper reaches of the atmosphere, the gas density is very low. In the lower reaches, the gas density is very high. This is the distribution of the gases. As you are there within the more number of gases, when the gas particles get heated up, you will find more heat energy. You will experience more temperatures. The terrestrial radiation. What do you mean by terrestrial radiation? The very important one is called as terrestrial radiation. Whenever you are talking about the sun's energy is reaching the Earth's surface. The sun's energy reaching the Earth's surface in a form of short wave form. It's called as short wave form. How the sun's energy is reaching the Earth's surface? It is in a short wave form. What do you mean by short wave form? Like this, something like this. It is how the sun's energy is coming. When the energy is coming in a short wave form, what happens to the frequency? The frequency is high. Meaning what? 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of terms that is taken up is called as frequency. Frequency is high. But once the Earth gets heated up, Earth absorbs the heat energy. After absorbing the heat energy, it will be releasing the heat. This released energy is called as terrestrial radiation. Terrestrial, Earth surface radiation giving out in the form of the same electromagnetic waves. When the Earth is giving out the heat energy, the Earth's energy is in the form of long waveform. It is in the form of the long waveform. What do you mean by long waveform? It is something like this. When it is a long waveform, what the frequency? See the frequency 1, 2, 3, only the frequency is less. In the same distance, see if it is the same distance, if at all you are continuing this one like this one, 9, 10, 11, 12, 13. 13 is the frequency here, here 3 is the frequency. Got the point? This is the long waveform, this is a short waveform. What happens when the frequency is high? What happens when the frequency is low? When the frequency is high, meaning what? Energy is intense. Energy is very, very furious. It can travel very fast. It can penetrate to a longer distance. But whereas when the frequency is less, what happens? The heat energy will be moving slowly like this one. When it is moving slowly, what happens? It is the one which will be heating up the gas particles. The gas particles are heated dominantly by the terrestrial radiation, not by the incoming, not by incoming solar solar radiation. This is called as insolation. What is insolation? Incoming solar energy is called as insolation. What do you mean by insolation? Insolation is nothing but incoming. See this one? The very word is coined from taking some of the letters of the statement. Incoming solar radiation, nothing but insolation. This is insolation. The insulation is always in the form of short wave. Whenever it is in the form of short wave, the ability to heat the gases is low, whereas the long wave, as it is moving slowly because of less frequency, it makes the gas particles to heat rapidly. And so all the gas particles get heated up. When all the gases are heated up, the people who are located within the gases will be having more suffocation. Whereas for this fellow, see this fellow, the surface area itself is less. Therefore, the amount of energy received is less. When the amount of insulation itself is less, the amount of radiation is also less. Moreover, the gases that are present are also less. When the gases are less and the heat energy released is also less, therefore the temperatures are very low. That's why on the top of the mountains you can find the ice formation. On the top, very top of the mountain, what you can find is ice formation because of low temperatures. That is the reason all the hill stations are very pleasant to stay. Why? Because of the altitudes. The next one, nearness to the sea. The next very important is nearness to the sea. Suppose if this is India, this is the city called as Delhi. This is the city called as Bombay. Right? This is Delhi. This is Bombay. When the temperatures of Delhi are compared, the Delhi temperatures in summer will be rising nearly to 50 degrees centigrade, but the Delhi temperatures in winter will dip to almost all 1 degree centigrade. This year the temperatures were 1.2 degrees centigrade. You know this one. In Delhi, the temperature was 1.2 around some 28th of December and till January some 4th or 5th. The temperatures were around some 1.2. Night temperature dipped to 1 degree. This is what the temperature of Delhi. Why this summer temperature is very high? Why the winter temperature is such a low? Though the sun for both Delhi and though the sun for Delhi and Bombay is one and the same, whereas see the Bombay temperatures, Bombay summer temperatures, a very very peak summer temperature rises to around some 42 degrees centigrade, whereas the winter temperatures around some 15 degrees centigrade. This is what the Bombay temperature. If it is further low in the winter, maximum to maximum less temperatures are around some 12 degrees centigrade. 12 degrees. Then what is the difference? The difference is 30 degrees here, whereas here the difference is 49 degrees. This is called as the range of temperature. A range. The range of temperature is very high whenever the places are located inside the continents, far away from the water body, like this way. Far away from the water body. Who is far away from the water body? It is Delhi. Delhi is far away from the water body. Therefore, the impact of water body is not there in Delhi. Whereas Bombay is located in the coastal area. Therefore, you can find the impact of water body on Bombay. Due to this impact, Due to this impact, the Bombay temperature, it also wants to rise to 50 degrees centigrade during summers, but someone will be pacifying. Someone will be pacifying means what? The water body that is present will be will be sending the cool air onto the surface and reduce the temperature. On the same lines, even in winter, when the land temperature is dipping very low, but by the side the warm water makes the land mass to have some warmth. Therefore, the water body will be controlling. It will be having some influence on the surrounding lands. But whereas for the regions like Delhi, where the landmass, when the landmass is located deep inside the continents, there is no impact of the water body. Such a concept being located deep inside the continents is called as continentality. Is called as continentality. What do you mean by continentality? Being located deep inside the continents is called as continentality. Why the Delhi range of temperature is very high? Because of continentality. This is what the answer. Why the Bombay temperatures are moderate in nature? Because of maritime influence. These are the terms which are geographical terms. Maritime influence, nothing but the influence of the water body. This is the influence of the continent, this is the influence of the water body. This is what called as the nearness to the sea. Whenever a city is located close to the water body, then the temperature range will be moderate, not high temperature, not low temperature. But whenever the cities are located deep inside the continents, you can find the influence of continents, which is called as continentality. Due to continentality, the temperature range is very high. The range of temperature is very high. This is about the continentality. This is about the nearness to the water body. Then the next one. The next very important one is called as the tilt of the earth. Let us see the tilt of the earth. The earth is tilted. Because of the tilt, the earth is having so many seasons like this one. Suppose if this is the orbit of the earth, this orbit, this is earth. Earth is tilted like this. It is. The northern hemisphere is facing the other side of the sun, and at this position the northern hemisphere is facing exactly the sun. Got the point? Earth is supposed to be straight like this. It is supposed to be straight like this, but it got tilted at an angle of 23 and half degree to the axis, and it got tilted at angle of 66 and half degree with respect to orbital plane. See, with respect to this line, it is 66 and half degree. With respect to this line, it is 23 and half degree. You can write anything like Earth got tilted at an angle of 23 and half degree with respect to axis. Earth is tilted at an angle of 66 and half degree with respect to orbital plane. Orbital plane. This is what the statement. Earth is not straight, but it got tilted at an angle of 23 and half degree with respect to axis and 66 and half degree with respect to orbital. When the position, see the position, because of what is called as elliptical orbit, it's not circular orbit. Sometimes the Earth comes close to the Sun, around some 147 million kilometers. Sometimes the Earth will be far away from the Sun, 152 million kilometers. This position, when the Earth and the Sun are very close, it's called as perihelion. It's called as perihelion. What do you mean by Helios? Helios in the Greek language means what? Sun. Peri means what? Near. Earth comes very close to the Sun on 3rd of Jan. During 3rd of Jan, Earth and Sun are very close. What is the distance? 147 million kilometers. Whereas the Earth will be far away from the Sun during the position called as aphelion. During this point of time, the distance between the Sun and the Earth is 152 million kilometers. Helion means what? Sun. Up means what in the Greek language? Far away. Far Sun position. It happens on 4th of July. It happens on 4th of July. These are the two positions which are very, very important. And the Earth will be keep on revolving around the Sun like this. When the Earth is revolving around the Sun like this, sometimes the Earth will be at this position, where the sunrays will be falling perpendicularly over the equator, and sometimes the Earth will be somewhere here like this one. This is called as the winter solstice. Winter solstice. It happens on 22nd, 23rd of December. Whenever it is winter solstice, means what? Sun rays are falling at the southern hemisphere. Sun rays are falling in the southern hemisphere like this somewhere, right? But all I am showing this one. 3rd of Jan and 23rd of December is almost all nearby. So just take only one earth instead of drawing so many earths in order to avoid the confusion. Let me take only one position here. This is the position. When the sun rays are falling perpendicularly to the southern hemisphere, why it should be called as winter solstice? Because the sun rays are not falling straightly on the northern hemisphere, and it is winter in the northern hemisphere. Whatever is the season, this statement is very important. Whatever the season for northern hemisphere, that is the season for the entire world. Why? Because 3/4 of the land mass is present in the northern hemisphere. Though the sun rays are falling perpendicularly over the southern hemisphere, it is summer for the southern hemisphere, but for northern hemisphere it is winter. Therefore, it is called as winter solstice. During this point of time, the nights are prolonged in nature, whereas days are shorter. Almost all nights will be 14 hours, days will be 10 hours. When the earth starts moving right from here to here like this one, by the time it is 21st of March, the sun's rays falls perpendicularly over the equator. This position is called as equinox. Meaning what? The insolation is falling exactly over equator. Equally distributed insolation is called as equinox. Then the duration of nights and days exactly 12 hours and 12 hours for the northern hemisphere and the southern hemisphere. The day will be 12 hours of time, night will be 12 hours of time. This is called as spring equinox. It's called as the spring equinox when the earth is somewhere here like this. When the earth is somewhere here like this, what happens? The sunlight falls perpendicularly over the northern hemisphere, and this is called as summer solstice. It happens during 21st of June. During this point of time, the days are prolonged. 14 hours of day will be there, night will be just 10 hours. This is what the summer solstice. And when when the earth rotates like this and it falls here again, the sunlight falls exactly over equator. It is on 23rd of September. This position again is called as equinox, meaning what? The equal amount of insolation is there both in the northern hemisphere and the southern hemisphere. Therefore, the days and nights are equally distributed. This equinox is called as autumn equinox, and again the sun rays reach here, where you can find the sun rays falling on southern hemisphere, which is called as winter solstice. This is the tilt of the earth. Because of the tilt only, you can find the winters, you can find the spring, you can find the summer, you can find the autumn. All these seasonal variations are due to the tilt of the earth. Rotation and revolution of the earth makes the changes in the seasons, at the same time duration of the sunlight in the northern hemisphere and the southern hemisphere. The duration of the northern hemisphere and the southern hemisphere with respect to sunlight changes the hours of days and night, like this one. Sometimes you can find exactly distribution of day and night within 24 hours of day. 24 hours or day, 12 hours will be the night, 12 hours will be the day. This is what the entire concept called as the tilt of the earth. A very, very important concept. It's called as the tilt of the earth. After the tilt, what is the other latitude, altitude, distance from the sea? We have completed latitude, completed altitude, distance from the sea. Tilt of the earth, oceanic currents and the air masses. Come on, let us see the oceanic currents and the air masses. What are these oceanic currents and the air masses? Suppose if this is the land, in between oceans are there. In the oceans, the water will be keep on circulating in a definite fashion, like this one. The water will be circulating in a definite fashion. This definite circulation of the water in the ocean is called as ocean current. It is called as ocean current. When we say it is equator, if it is the polar region, 90 degrees polar region, the temperatures are very cold here. Here the temperatures are very warm. When the water is keep on circulating like this one, the warmth of the heat of the equatorial region is transported towards the polar region, and the cold of the polar region is brought towards the equatorial region, thereby moderating the temperature. Thereby the moderating the temperature over the Earth's surface. That is what is happening. This is the role of the oceanic currents. The definite circulation of the water in the ocean is called as oceanic currents. These circulations are moderating the temperatures. Not only these circulations, even over the Earth's surface, the global wind circulations are also there. Like the winds are circulating in a definite fashion, like this one. The winds of the air that is rising along the equatorial region is coming to the polar region, and from the polar region again the air is moving towards the equatorial region. This circulation, where they are called as the global wind circulations. The global wind circulations. The equatorial heatness or the equatorial hotness is taken towards the cold polar regions, and the coldness of the polar areas is brought to the equatorial region, thereby maintaining the global hydrostatic balance. Thereby maintaining the global hydrostatic balance. This is about the oceanic currents and the global wind circulations, which are the air masses that are circulating. Then, after this one, transparency in the atmosphere. Suppose if it is we people we are living here, it is right. The people are living here. Transparency in the atmosphere. Suppose the atmosphere is very clear, like this one. If there is a clear sky, then what happens? The sunlight can directly come into the surface of the earth, and the terrestrial radiation can move out. Suppose if the sky is completely covered with the clouds, like this one. When the sky is covered with the clouds, then what happens? The insulation which is supposed to enter onto the surface will get reflected back, like this one. The insulation which is supposed to come will get reflected back, thereby lowering the temperatures. Also, whatever the heat energy that the earth is releasing, it will be going up to here. Again, it will be pumped down, like this one. It will be pumped down. It will be hitting the clouds and will be coming down. Therefore, the heat energy will be trapped here itself. The new heat energy will not be coming out. Therefore, this also modifies the temperatures. Modifies the temperature. The transparency in the atmosphere. The transparency of the atmosphere. Transparency in the atmosphere matters a lot. The cloud cover. The cloud is having the ability to reflect back not only the insulation, not only it is reflecting the insulation, it is reflecting back even the terrestrial radiation. The terrestrial radiation. These are all the factors that are affecting the temperatures. Factors affecting temperature on the Earth's surface. In the next class, we'll talk about the heat budget, a very very important concept, heat budget, and the distribution of temperature over the Earth's surface and inversion of temperature. Right? These are the concepts we need to discuss in the next class. We'll discuss this one in next class. Until then, take care. See you. Bye bye. I will take leave here. Then we'll talk about the things in the next class. Take care.